Okay, welcome everyone. Um, I'll just wait 1 or 2 more seconds because there's just like 10 people joining at the moment, so that everyone can adjust and we are ready to go. Okay, that looks great. So thank you everyone for joining and welcome to our live webinar. Today's session is all about bounces and how to handle them intelligently. Our speakers today are Steve and Carlos from Halon. They'll introduce themselves in just a moment. And a short word about myself. My name is Franziska and I'm the Customer Success Manager at the CSA. I'll be here to support you throughout the webinar. If you have any questions, you can just send them to me in the chat. And a little bit on housekeeping. Yep. You are muted during the whole webinar. All questions will be answered at the end. Please use the chat function. You will find it on the right in your control panel. Send your questions to organizer and we'll be happy to answer them. All right, maybe you already know us, but just in case, the CSA's mission is to improve the quality of commercial emailing. We act as a neutral interface between mailbox providers and senders. And if you would like to know more about our daily work, how we support businesses, or about our certification manager, please reach out afterwards. And yes, we also want to say a big thank you to our supporters who accompany us throughout the year. That is DMARC, Advisor, Dimartion, Halon, and Spamhaus. Thanks to them, we can run these webinars and many other activities. If you would like to know more about them, please download our supporters booklet. You can find it on the right of your screen with contact details for each company. Okay, that's it from my side. Over to Steve and Carlos. They will kick off the session. All right, I will jump into your presentation and then the stage is all yours.
Thank you, Franziska. Good morning, afternoon, everyone, and thank you for joining us for our webinar From Chaos to Clarity, Optimizing Deliverability through Intelligence Bounce Classification. I'm Carlos Pereira, and I'm joined by my colleague, Steve Tuck. We are both excited to be here to talk about a topic that we are passionate about, how to efficiently manage email bounces. We know that bounce management can be a real headache, and our goal today is to show you a better way. We'll be exploring a machine learning approach that can bring much needed clarity to this often chaotic process. Now, let's get started. Steve?
Yeah, as a sender, do you often find bounce management to be one of the biggest obstacles in achieving smooth email deliverability, especially during IP warmup? Traditional approaches such as manual work and rigid regex-based rules, these often create more effort than solutions. And many teams get stuck in reactive troubleshooting, repeated tasks, and limited visibility, making it difficult to scale operations effectively. A more modern approach to bounce classification can help turn these challenges into opportunities by moving from manual fixes to automated data-driven insights. Senders gain a clearer view of the deliverability trends. They understand the real reasons behind bounces and can act quickly on actionable insights. And this shift enables a more proactive strategy, and it lays the foundation for a long-term deliverability success. Next slide, please, Franziska.
No, it is this one.
Yeah,
sorry.
That one. Yeah,
that this one, yes.
Yeah, thanks. So these are the points that we're going to cover in today's presentation. Firstly, who cares about bounce management, and a bit more about the classic regex-based approach, and then introducing machine learning and the why and how of that. So bounces are just a fact of life in email. particularly if you work at an email service provider. You're delivering billions of emails per year to a total audience of hundreds of millions, spread across a wide range of mailbox providers. And beyond those big mailbox providers, there are hundreds of regional players, particularly in areas such as Europe.
Yeah, I guess this is because email accounts are sticky, right? No one wants to tell all their contacts they have changed their email address and go through the pain of changing all of their logins.
Yeah. So depending on how you measure it, there are tens of thousands of mailbox providers around the world. And as an email service provider, you need to do a decent job of delivering mail to most of them. Some of that mail will bounce. And we know that at the simplest level, there are transient failures, which are the 400 range of responses, sometimes called soft bounces or temp fails. And there are permanent failures, the 500 range, sometimes called hard bounces.
Correct. And if you search for more information, you'll come across the RFCs and the ANA website showing the detailed enhanced status codes and all of that. But this still not that helpful. There is a great variation between mailbox providers, and not all of them use the enhanced status codes. And many of them use their own codes instead.
Yeah, and perhaps more importantly, it doesn't tell you how your system should behave in response. Responses vary a lot between mailbox providers, and the text can be vague. So does the response message rejected mean that you should take that person off of that sender's list?
Not always, right? Some responses tell you to slow down and maybe try later. But slow down what exactly? Just a particular campaign? Or the sending domain? Or even the IP that you are sending the email from? Or do you just slow down to that particular recipient?
Getting this correct is difficult. It's often a matter of judgment. It takes up a large slice of a deliverability person's time. And if you're overly cautious, much email is going to get delayed, which your customers don't like. If you're not cautious enough, you damage the reputation of the sending domain or the IPs, causing yet more headaches and even lost business.
And it's not a static problem. Mailbox providers sometimes add new codes. For example, around 2 years ago, several new codes came in with the Yahoo changes, right?
Yep. And the mailbox providers are trying to be helpful, giving detailed information on why they don't like your mail right now, indicating issues with DMARC, DKIM, SPF, and so on more transparently. And our goal is to provide more accurate, tailored behavior to the widest possible range of messages. Next slide, please.
Franziska, the next slide, please. Thank you. Anyone knows who this is?
Yeah, it's a Swedish guy actually, named Carl Linnaeus. And he broke new ground by classifying and subdividing the natural world into species. And he catalogued many forms of life, including hundreds of beetles. And today there are over 400,000 known species of beetle alone. And in his time, folks were collecting and naming beetles, but the underlying system had limitations as it's based on outside appearance. And we know today something that Linnaeus didn't, which is how to unravel and decode the strands of DNA that actually make each species unique, revealing deeper relationships.
Exactly, Steve. And that was a fundamental shift, right? Judging by the outside appearance to understanding the underlying DNA. That is precisely the trap that the email industry has been in. We've been judging bounces by their appearance, the first word that pops out in a bounce message, like blocked. But without understanding their DNA, the real root cause of the delivery failure.
Exactly. Each ESP has tried grouping bounces into categories to manage reputation and recipient lists. And this uses regular expressions, or regexes, to look for matches in the bounce text. Next slide, please, Franziska. So what's actually wrong with regexes then? Because these have been the standard solution to the bounce classification problem for at least 2 decades. Rules are carefully curated and updated by email professionals. But let's take a look at this message. It has in there, we've redacted the email address and the URL, but it's saying requested command failed because the user's mailbox was unavailable. Try again later. It then has a URL and it says Vade secure. Now, is this message a bad mailbox because it says mailbox unavailable? Is it policy related because it says try again later? Or is it just some other classification? And in fact, that is the actual answer that 3 different professional regex sets are giving to this code. And there are many other examples like this.
Yeah, actually, that's a recipient level error. This mailbox is temporarily unavailable. You can retry delivering the message at a later time. So in our system, we would tell you that this is a recipient error. The problem with regexes, right? There are main 3 issues. Regexes are hard to write. If you don't want to take more resources than needed, they are prone to errors. We write them while looking at one bounce message at a time without seeing all the 1,000 others that it will match on. And third, they are hard to maintain. Too much of complexity, so many different cases to keep in mind when you are changing a single one of them. This tricky example shows how it is hard to improve regexes. The list rules is read on a fixed top-down order. First one to match is the one that gets triggered. And this means that you have to put all the difficult outliers at the top of the file. Over time, you get many redundant rules, some of them that will never match.
Exactly. Humans are often too specific or too general when they're constructing regexes. And if you're too specific, then you're going to get skips or false negatives where your rules didn't match. Too general, then you're going to get mismatches or false positives. So over time, over those years, taking a reactive approach, adjusting your regex sets is going to have an unforeseen impact, which you can think of as being like a technical debt leading to mistakes.
You might think that this was a very cherry-picked case, but instead let's take a look at a broader picture, shall we? Next slide, please.
Next.
Sorry.
No worries. So here we take over 16,000 bounce messages and we classify them by 2 separate regex sets, which I've called these just set 0 and set 1 on those axes. And then we make a scatter plot. So this, for example, if both sets say other, then that's the big blue dot in the top left. But the rest of that row and the rest of that column shows where the results from set 0 and set 1 disagree, and so on, down the rows and along the columns. The biggest dots represent the most popular result pairs. And these are real examples of professional sets from senders that we have worked with. The comments in these files show that they've been actively maintained for at least 12 years, and they each have 300 to 500 rules.
But you can see that there is some agreement, mostly the big dots top left, but also a lot of scatter, cases where the results disagree.
Yeah, and why do these sets even have similar names? Well, it's because they have similar origins, going back around 20 years ago, and they have diverged a bit as they have been updated and maintained by their owners. And I see that here the majority of messages are landing in the categories of other, spam related, and policy related. There is a reasonable amount of agreement on these, but the other category is basically useless. You don't know what action to take. And even policy related, it's not that useful in today's world, particularly after the Yahoo changes. You should slow down the message stream, but what is the scope? Does it mean you should slow down the message IP, or should you slow down the sending domain, or just that particular campaign and job ID? Next slide, please.
So let's see how machine learning can help. Building the model is a lot of work. Maybe folks who collected build tools think that it's fun. It needs good input data to train the model. We use over 9,000 distinct bounce messages. We normalize the messages to keep the important features and remove all the noise. We use annotations tools like the one that we are showing here, Prodigy, that guide the process, but it's still a lot of manual work. We also need to agree on the categories. We have chosen these so that the next action to take is clear. They are fine-grained enough so that you know what to do about the issue and the scope. And this is why it is called bounce next action classifier.
And another thing, we don't have an other category. The categories are as specific as possible with minimal overlap.
On the slide, there is an example message that the traditional regex systems classify as blocked because it contains the word blocked. But as you can see, that is not the case. The cause is DNSPTR, and that is what we return. In this case, machine learning takes the full message into account and not just the first word that pops out when you look at it.
Yeah, and to get good results from machine learning during the training phase, it needs multiple people looking at the same messages, voting until you reach a consensus. And that was the work we've done here. And after all of that, finally, we were ready to build and test a machine learning model.
Machine learning is usually associated with heavy computational cost. While that is true for large language models such as ChatGPT, that is not what we are using here. Next slide, please. Will it be slow? No, we won't. Even on a laptop, the Halon Delivery Guru, Bounce Next Action Classifier, or BNAC as we call it, zooms through thousands of classifications per second. On a production platform, it will be even faster. Unlike large language models, it does not require any GPU to run. Ordinary CPUs are just fine.
And here we're making an API call to get each result from a small Python script. But because it's an API, you can use this service in any programming language and any compute environment. And as we mentioned, the output categories tell you the next action to take on the message streams and the scope to apply.
Exactly. And when we say action, we mean something truly specific. Categories don't just say spam. Instead, they are specific to the cause of the problem and the action that you should take, even for a bounce message that it has never seen before.
So just imagine if Linnaeus, the guy from the 18th century with the funny hair, had access to a modern DNA sequencer. He could have put together the underlying relationships. When he got a specimen that has not been seen before, he could place it correctly on the family tree.
And placing things correctly on the family tree is a perfect description of what a well-trained machine learning model can do. And this is why it is different. There is no need to maintain hundreds of rules in a constantly changing world. It can actually be faster than running the hundreds of regex rules. It easily adapts to data that it has never seen before. So even if the word blocked is not there, it will figure out from the rest of the message. It gives you the categories that you can actually act upon.
Is it perfect? Well, no, not yet. But the more data we train on, the better it gets. And we'll never actually reach perfection, but we're steadily improving the performance. Next slide, please. So all Halon clients have access to this suite without additional charge. It also runs on your premises, and it can be run alongside your existing regexes, so you can compare the results for yourself. So you could also use it to spot anomalies, for example. For example, you could just run it on your other category.
We would like you to share data, but it is optional. What about privacy? Of course. For training data, we replace all known variable values with placeholders. We don't want your email addresses or unique IDs. For example, if we want to know that there is a URL from Spamhaus in the bounce message, but we don't care about the exact URL. Likewise, for IP addresses, names, email addresses, domains, and so on. As you can see in the example there, you can see how the export data looks like, and it is aggregated, meaning that you see the counts and see how many of those specific messages we got in that system.
So to go back to the beetles for a moment, we're not trying to capture all the beetles in the Amazon rainforest. We only need a few carefully prepared, sanitized examples. And we have several Halon customers already providing the anonymized data to us. And we are actively seeking more folks to collaborate with.
Now we have shown how accurate bounce classification helps you identify the actions that you need to take. And this is particularly important when you are warming up new IPs. You have to pay close attention to the responses that you are getting. Next slide, please.
So here is how we do warm-up. Each mailbox provider is responding individually to messages. So an effective warm-up schedule needs to be specific to each mailbox provider. Each IP address and sending domain has its own reputation, which gradually builds up over time. So the schedule needs to be aware of which IPs are being used, which are already warm, and which are still warming up.
A good use case for better bounce management is to provide intelligent IP warmup. As the mailbox provides response to messages, the response code seen by the system can then be used to shape the future warmup volumes. Next slide, please.
Thanks. So we can actually measure the usefulness of the IP warmup component by comparing it against the 6 Halon core principles. And there are actually 3 of these that apply. The first one is to be proactive, not reactive. And this comes from effective automation that enables you to safeguard your service while also sleeping easily at night. And you can reduce your manual triage work and escalations.
The next one is automate, do not repeat. No one likes performing repetitive tasks. Email operations and deliverability teams are busy. Automation helps them focus on the strategic and decision-making aspects, leaving machines to do the boring bits of stepping up rates over time to a schedule.
And then there's visibility. There's an ever-present risk with warm-up that things can go wrong quickly. Mailbox providers can start deferring your mails or even bouncing them. We have heard from email folks who are doing it the old way that they stay awake at night just so they can check their dashboards for problems. And there has to be a better way than that. You need visibility that directly relates to the warm-ups that you are doing. And that means specific dashboards like the one we showed. Next slide, please. So thank you for the opportunity to share with you the progress that we are making. And we would love to answer any of your questions.
Thank you. I'll hand over to Franziska now.
Perfect. Thank you so much, both of you. That was really interesting. Let me check what we got. I've seen a few questions coming in already. Okay, one is, how can better bounce classification improve overall email deliverability and reputation management?
Shall I start and maybe you add to this, Carlos?
Sure.
So it's absolutely critical that you do this because the mailbox providers are running a reputation score against every mail stream that they see. And if you are not responsive to the codes that they are sending to us, then that is going to lead to big problems later on. And the way that their reputation models work is if you make a mistake or you send the wrong kind of mail or unengaged mail, it's not that they're punishing you, it's that they are protecting their users. And it's kind of punishing you as well as a sender. But if you ignore those signals, then that tells them that you're the worst kind of sender who doesn't respond to those signals. I hope that helps. Carlos, anything to add?
Yeah, when you're doing it with regex and other approaches, it's not like you're trying on purpose to be bad, behave bad, or ignore what they are saying. It's just that it is very difficult to look into the thousands of bounce messages that you are getting and to take the right decision on them. If you are doing just with regexes, it might mean that, as we have shown here a few examples, that you take the wrong action based on the regex, and it is not your fault, really. It's a very complex problem. Once you can have a better approach with machine learning, you can have a better classification, which means that you are more in control of the decisions that you are making. Therefore, you can be more accurate in the responses that you are taking. Hopefully that makes sense.
I think to add, Franziska?
No, I think that's clear. That already answers like more or less the second question. That was like, what is the difference and advantages between like classical traditional regex approaches and the machine learning? So that goes in well. I've got a different question in there, like more technical related. That was the question whether this or the analysis that you're doing, whether that is coming in real time or is that happening later on? How does that work?
It works in real time. Yeah. So as every message is coming, it flows through the API to the model, and the model responds in real time. So
maybe I can clarify. That's the classification part. So you will get the answers back in a millisecond from this API call. There is then a longer process where we, with your permission, we collect those sanitized results. And when we see a significant deviation between what our model is predicting and the results that are out there in the wild, then we will retrain our model and we will release a new version of the classifier, and that gets pushed out and made available to all our customers.
Okay. I think that's clear. Then we have from the same person coming in question regarding which domains you consider. Is it like all domains that are out there, or is it just the top ones? Where can you help?
I guess this relates to the collecting of information and classifying, or to both, I guess.
To both, I suppose. And the answer is we take all domains. When we take the bounce classifications, as we have shown in one of the slides, we take the counts for them. So the bounce messages from the domains, from the big players like Yahoo, Google, and Microsoft, they take higher relevance, but it's not like we ignore all the other players. We take them into consideration as well.
Okay. I think that's clear. If not, that's like a general note to everyone. If anything is unclear, just reach out to us afterwards, or if we don't answer your questions correctly, please feel free to reach out. I've got a few more questions here. I think we still have some time to answer them. Do different mailbox providers require separate warm-up strategies, and how do you manage that?
Oh, they definitely do.
Absolutely.
So in our plugin, is what you can see is that we would do different strategies. Your reputation with the different providers is different, right? They don't use the same tools to assert your reputation. It might be even that you're not sending exactly the same traffic to all of them. So it's always a pair of your IP domain and the receiving end. So when you're doing an IP warmup, you need to take in consideration that, and it needs to evolve over time. So you're basically doing a warm-up to every of these pairs, and you need to be adjusting the rates that you're sending the emails to them completely independently. Getting a good reputation with and being able to send a lot of emails to one of them does not necessarily put you in a better position to send to the others. In some cases, they share some tools, and in some cases, they don't. So you need to be very careful with that process. Steve, anything that you want to add?
Sure. Just to clarify, the automation that we provide allows you to set, let's say you decide a 30-day schedule for warm-ups, and you can have individual ramps for each of the mailbox provider groupings. So you can set that up in advance. It does still require your deliverability team to have knowledge of, for example, that Microsoft is more sensitive in the early stages than others, for example. So there is still really a place for the human skill and knowledge, but then we automate the boring parts of actually running that 30-day schedule.
Okay. Yeah,
and it can be longer or shorter than 30 days. That's just an example.
So it's all adjustable, and that leads perfectly fine to the next question. How does your model adapt to changes in mailbox provider behavior over time? So we all know that it doesn't have to stay as it is. How do you handle that?
Exactly. So our customers that agreed on sharing data with us, we retrain the model very often with the information that they send, and we adjust the models to that. And if there is any customer that reached to us and saying that they are seeing significant amount of false positives, we retrain it straight away and send back to them.
So it should be in the interest of your customers to share data with you, right? So the more they share with you, the better you can train the system.
Yeah, it's the better it is for everyone that is on that sharing pool. Yeah, there's no sidelines for them, as in there's no information that they are leaking or anything, and there's the only benefit for everyone that they are getting better bounce classifications. So
yeah,
that does actually, it raises an interesting dilemma for an email service provider, in that everybody wants to be the best, but are they ready to share data which makes it better for other people too in the market? And that is an open experiment, if you like, to see how open people will be.
Perfect. I don't see any questions at the moment. Maybe we'll give the audience another minute to send in questions, or a few seconds. Don't want to waste too much time of everyone. Everyone is busy. No questions coming in at the moment. If there is anything, as mentioned before, please feel free to reach out and send it through. We will be sending out the recording of this session anyway to you. There might be blog articles around that topic. If you need contact details, you have information in the booklet in this chat here. And if not, you can reach out to us afterwards. Thank you again, Steve and Carlos. I think that was very helpful for everyone. Thanks for your time. And yeah, have a great afternoon, everyone.
Thank you very much.
Thank you. Bye-bye.